our depth. This is our depth. Okay, so the whole thing is 205, all in millimeters. Okay. Then the next thing is what do you call this? So now you guys, I've been drilling you guys on what is a flange, what is a web. Now when you see a question, I know what is this already. This is the flange. F is for the flange. So the width is equal to 166, right? And then the thickness, okay, the thickness of the flange, which is equal to 11.8. Okay, this is no different from my term test, right? Right. So in my term test, what I'm going to do is I will tell you, okay, you're going to use W200. And if your student number end with 9, you use W200 times 59. You get what I mean? Right? We can do this also, right? Okay. Then the TW, okay, now you understand what is W stand for. W is stand for what? The web. Okay, now all this is not just the what dimension. Now you physically can visualize what is a web now. Okay, and I hope you do. And this is 7.24, right? Then the good thing is now we are given IX, right? And then we are given what? IYY. Okay, we are given these two terms. Okay, so the first thing to do, okay, be safe. Okay, we have to do things that are safe. Don't do things that are risky. Okay, this is not the time to take risks yet. Okay, because it's not worth $1 million. If it's worth $1 million, take the risk. If it's worth your education, don't take the risk. Okay, so now based on this orientation now here, right, we will now know the transformation that this is our what? X, right? And then this will be our Y, right? And then you use right hand rule, right? The smaller alphabet go to the earlier alphabet, go towards the later alphabet in terms of alphabetical order. And then this is your Z. Okay. So as I say again, 3D problem, 2D world. Okay, it's a true 3D problem now. Okay. So some of you look this like, whoa, okay, don't panic. Okay, you guys, if you guys can do what we did for tutorial today, this is Mickey Mouse stuff. I will tell you that. Okay. Wait, Mark, but now I don't know how to make my cooking good. Mark, you cheeky sort. Mark, okay, I'll tell you learning things from the internet. Okay. You learn yeah, myself take a bit of break because I'm not going to solve this today. So the thing about watching the internet is this. Okay, I cook curry. I love to cook curry. And one time my curry became bitter. Okay, and the reason why my curry became bitter is I think I put too much curry powder. So the solution is to put and anyone cook curry that the curry is bitter before? Anyone?
Add some water.
No, add water, you get diluted, you cheeky sort. So the solution is not to add water. The solution is to add salt. And it works. Voila. Okay. Now, why it works, I have not a clue. But I know I can eat my curry and I don't become hungry. The next time when I cook a different dish, right, the taste is bitter again. Do I put salt? Question for you guys. No answer.
Wait, like another curry or another kind of food?
A different dish. Maybe Irish stew. Okay. Yeah, Irish stew using Guinness. It tastes bitter. What do I do?
Go on YouTube to look up the solution.
So the answer is not necessarily salt, is it?
Yeah, exactly.
Right. So what I'm trying to tell you is this: whatever you look on the internet has boundary condition, limited to a certain facts, limited to a certain condition. So one is curry, the other one is Irish stew. Maybe Irish stew you don't put salt, okay? You put more Guinness or drink more Guinness and then eat the Irish stew. Okay? So learning things from internet I'm not saying you learn nothing. You can learn something, but the solution is very unique. I always look into internet on how to fix my car headlights, how to change it, or how to fix my washing machine, because I don't do damage then. Okay, right? It's sometimes quicker. But learning things that has fundamental physics like this, okay, it's not always a good thing to learn from internet. Okay, that's all I have to say. And I hope this were when you look at solutions from the internet, be very cautious. Okay. So one of the big learning outcome from my consulting business that I do is I was told that I have to teach. These are my industrial partner for my consulting. I always been told, like, Eugene, can you teach your engineers, okay, to identify what is correct and what is wrong when they get information from the internet? Very, very important. Okay, so they don't like answers, industry. They don't like answers. Oh, I watch it from the internet and internet tell me this. It has to be correct. No, okay, it's too expensive to test. Okay, now stop. I will stop blabbing now. Okay, so we have drawn. This is our X. This is our Y. And this is our Z. Okay, so the first thing I'm going to do, I'm going to look at my XZ plane. Okay, so we're going to apply what we have learned. Okay, we're going to apply. So we're going to look at our X, okay, Z plane. Okay, so XZ, and then this is rotation in the Y. Okay, so I'm going to sketch that first. Okay, so this is what? This is 500, 600. I'm going to sketch 600, 150. So 150, 600. So 2, 4, 6. I'm doing 600 up to the element, okay? And then 75, 75. Okay, so this is my view now. Okay, so I'm watching that on my XY plane. Okay, so I'm going to draw where the element, where my element A is. Okay. So this is where my element A is. Okay, I'm just going to put somewhere around. So this is my element A. Then, as usual, I'm going to insert my our neutral axis. Right, so that's my neutral axis, and the point element A is 75 from one end. Okay, and to check, the width BF is 166. Okay, so 75 is somewhere around here, right? 75. Okay, so it's not exactly on the what? On the neutral axis. So that's what we identify. So next we put in our what? We put in our forces. Okay, so we have a 25 kilonewton here. Then we have 8 kilonewton. Okay, so twice. Okay, remember what I told you? Have twice. And then we have our 100 kilonewton from the vertical, right? 100 kilonewton. Okay. So as the rule apply, we only analyze the real arrow, cross and dots. We ignore it. Okay. Right. So now we know that we have a the 100 kilonewton is acting on the neutral axis, right? So P Z is equal to 100 or minus 100 kilonewton. Why I put the minus? Because we know that it's going to induce a what? Compression. Right? We are going to induce a compression. So with here, we know that stress in the Z direction. So we are calculating stress in the Z direction is PZ over A. And then for this case on element A, okay, on element A, it is going to be compression. Okay. Now, guess what? Let's do something on element B also. Okay. So let's look at element B down here. So I'm going to sketch out element B. Okay, I'm going to do both. Right. So this is our element B. So we also know, right? Element B due to PZ is also going to see a compression. Okay. So that's the first thing. Okay. Then next we come to our 8 kilonewton. Okay, our 8 kilonewton. Okay, so the 8 kilonewton, right? We're gonna take a distance to the element, right? Because the perpendicular distance is parallel, right, to the neutral axis. So you take the distance to the element. Okay, so that's what we're going to do. So this will be in moment in y. Okay, so I'm going to take clockwise to be positive. Moment at y is equal to it's going to be twice of the 8,000. Okay, so 8,000 twice of the 8 times 10 to the power 3, and the perpendicular distance, so where the 8 kilonewton twice is 0.6. And if you look at that, is going in the clockwise direction. Sorry, counterclockwise direction. So this will be equal to 2 times by 8 power 3 times by 0.6 is equal to 9,600 Newton meter. Right. So we know that it is going to go this way. Okay. So this is moment about y. Okay. So moment about y, the head of the arrow is compression, the tail end is tensor. Okay. So from here we know that stress in the z direction is equal to my. Now it's important now to be very sure about your formulas. Okay, like what I taught you guys, right? Bending moment is my divided by Iyy multiplied by x. Okay, x distance. Okay, x distance. So from here, you know that element A, right? Element A is going to be compression. And element B, right? So element, come on, Eugene, standardize what you're doing. Come on. Element B is going to be it's going to be tensor. And then from here, we also know that there's a Vx. Okay, the shear force is twice 8 times 10 to the power 3. Right. So this is equal to 16 times 10 to the power 3 Newton. Right. So for this case, right? For this case, we know that so the formula is what? So the formula is shear stress. Okay. Later on, we talk about shear stress in what direction. So just do shear stress. So we know that this is Vx over Iyy, right? Qy divided by T. Okay, divided by T. Right. So we know over here, we know that the stress for element A and element B, right? Now shear we have to be careful. I'll tell you why shear we have to be careful, because it's going to be thin wall analysis, right? It's going. So you can start. So we know that over here, some of you are like, oh, here we go again. Here we go again. So we know that this is a thin wall analysis, right? So for this case, we are going to use this diagram over here. Okay. Now listen. I'm not just teaching you about how to break down the forces, okay? I want you also visualize. Is this value going to be 0? Is it going to be max? Okay, I want you to have a sort of